This is the deepest man-made hole on Earth, but when they reached the bottom of the hole, they heard something very terrifying.
Now, I've got a clean copy of it now, and I warn you, this could scare you.
For nearly 2 decades, Soviet scientists drilled into the Earth expecting silence, stone, and heat. What they found instead shattered geology textbooks and unsettled everyone who heard it.
Scientists were very surprised that life could even exist or could be found that deeply.
At a depth no human had ever reached, the Kola Superdeep Borehole revealed signs that challenged logic, time, and even life itself. The hole meant to prove supremacy. The Kola Superdeep Borehole did not begin as a strange science experiment meant to satisfy curiosity. It began as a Cold War challenge. In May 1970, when the Soviet Union was locked in a long and bitter struggle with the United States, Soviet leaders approved a project near the Norwegian border that was meant to send a message to the world. They would drill deeper into the Earth than any country had ever managed before. This was not only about learning what lay beneath the ground, it was about power, pride, and proof. The goal was to show that Soviet science and engineering could master not only space, but the planet itself. At the time, confidence was high. Soviet engineers and scientists believed they understood the Earth's crust well enough. For decades, researchers had used seismic waves from earthquakes to build models of what lay below the surface. These models suggested neat layers of rock, clear boundaries, and predictable conditions. According to these ideas, the deeper one drilled, the more pressure and heat would increase in an orderly and manageable way. The Earth was thought to be quiet, passive, and unchanging. It was something to be measured, not something that could respond. The early years of drilling seemed to prove these beliefs correct. The drill moved steadily downward through hard granite. Rock samples brought up from the depths matched what the models predicted. Instruments showed temperature increases that followed expected patterns. Each success made the team more confident. Reports sent to Moscow spoke of steady progress and technical triumph. Any doubts that existed were pushed aside by results that looked clean and reassuring. But as the borehole passed 3,000 meters, small problems began to appear. The drill sometimes shook in ways engineers could not fully explain. The resistance of the rock changed suddenly without warning. Temperature readings rose faster than expected, then fell, then rose again. At first, these issues were blamed on faulty sensors or minor technical errors. Crews recalibrated instruments and adjusted procedures. No one wanted to suggest that the models themselves might be wrong. The human pressure to continue was intense. This project had become a symbol of national strength. To slow down or question the plan felt dangerous to careers and reputations. Engineers worked long hours in harsh northern conditions, driven by duty and fear of failure. Some felt unease but kept it to themselves. Others felt a growing tension they could not name. The deeper the drill went, the less familiar the Earth became. Over time, it became harder to ignore that something was wrong. The rock did not always behave like solid, lifeless stone. It fractured in unexpected ways. Tools wore down faster than predicted. Heat levels climbed to numbers that made crews nervous, even when official reports tried to sound calm. What had once felt like a controlled operation began to feel unstable. The Earth no longer seemed like a silent object waiting to be studied. It felt active, as if it were reacting to the intrusion. Still, the drilling continued. Pride, momentum, and political pressure pushed the project forward. No dramatic disaster occurred. No single moment forced a stop. Instead, a slow and creeping fear settled in. The gap between theory and reality grew wider with every kilometer. Scientists who had trusted their charts and equations began to realize that those tools were built on assumptions, not certainty. The most unsettling moment was still ahead. It would not come from a broken drill or a collapse of rock. It would come from the sudden realization that something scientists were completely sure should be there was missing. That absence would crack their confidence far more deeply than any mechanical failure ever could. the layer that was never there. By 1974, the drilling at Kola had reached a depth that Soviet geophysicists had been waiting for with near certainty. According to decades of seismic surveys conducted across the Soviet Union, the Earth's crust was supposed to change at around 7,000 meters. Granite, the hard rock near the surface, was expected to give way to basalt, a denser and darker rock believed to form the lower crust. This change was known as the Conrad discontinuity. It was not a minor idea, it was a cornerstone. Geological theories about how continents move and estimates of mineral resources all depended on this boundary being real. When the drill passed that depth, the mood at the site was tense and focused. Scientists expected a clear signal in the core samples. They expected a sharp change that would confirm everything they had been taught and everything they had told their government. That moment never arrived. The drill kept pulling up granite. The rock looked the same as it had hundreds of meters above. Its composition was the same. Its structure was the same. There was no sign of basalt at all. At first, disbelief took over. Researchers assumed something had gone wrong. Measuring tools were checked and adjusted. Samples were tested again and again. Teams from different institutes reviewed the data independently. But no matter how many times they checked, the answer did not change. The granite continued without interruption. The boundary that was supposed to be there was simply not present. As the reality set in, the atmosphere shifted from confusion to deep unease. This was not a small correction. If the Conrad discontinuity was not a real physical layer, then seismic surveys had been misread for decades. The reflections that scientists believed marked solid boundaries were not showing layers of different rock. They were showing changes in how the same rock behaved under extreme heat and pressure. The Earth was not neatly stacked. It was reacting and changing as conditions shifted. This realization shook the scientists involved. Some felt a shock. Others felt fear. Many felt a quiet dread as they understood what this meant for their entire field. If seismic data could be so misleading at one depth, it could be misleading everywhere. Much of what they thought they knew about the deep Earth was built on indirect signals, not direct evidence. Soviet officials quickly grasped the danger of these findings. Publishing them openly would call into question not only geological science, but the competence of Soviet research itself. In the tense climate of the Cold War, that risk was unacceptable. So the data was restricted and classified . The truth was buried almost as deeply as the borehole itself. But hiding the discovery did not make it less real. It made it heavier. The scientists at Kola continued their work knowing that one of their strongest assumptions had collapsed. If a boundary this important could vanish, then every prediction about what lay below became uncertain. The ground beneath them no longer felt solid in any sense. With the belief in orderly layers now broken, the next discovery would expose something even more frightening. It would show that the Earth's crust was not only misunderstood, but far more open and unstable than anyone had ever imagined.
One thing that surprised them was they discovered a lot of water deep, deep down in the borehole, way below where you would find groundwater or any effects of ocean water.
Water that should not be possible. Water was never supposed to exist at those depths. Every accepted model at the time stated that beyond a few kilometers below the surface, the Earth's crust would be crushed shut by pressure. The rock should have been dense, sealed, and completely dry. Any water, scientists believed, would either be forced out long before or destroyed by heat and chemical reactions. This idea was not debated. It was trusted as fact. As the Kola Borehole moved past 3,000 meters and continued toward 6,000, something deeply unsettling began to appear. Core samples brought to the surface were damp. Fine cracks in the rock held liquid water. This water was neither steam nor residue. It was liquid, trapped under enormous pressure, surviving temperatures that should have made its existence impossible. At first, the discovery was dismissed as a mistake. Some suggested that drilling fluids had leaked into the samples. Others blamed contamination during handling. These explanations offered comfort. They preserved the old models, but testing quickly destroyed that comfort. Isotopic analysis, which involves testing the atomic signature of the water, showed that the water did not originate from the surface. Its chemical makeup was different from any modern groundwater. It contained gases that could not come from shallow circulation. This water was ancient. It had been locked deep within the crust for millions of years. The conclusion was terrifying in its simplicity. The water had not fallen in by accident. It had moved downward slowly, over vast stretches of time, through tiny fractures that scientists insisted could not exist at those depths. The crust was not sealed. It was cracked, not violently, but quietly. It shifted, opened, and allowed movement. As investigation continued, another disturbing detail emerged. The water did not spread endlessly downward. It stopped at a specific depth. The stopping point did not match any known rock boundary. Instead, it matched a sudden change in pressure behavior. The Earth was not divided only by material. It was divided by how it responded to force. This forced scientists to rethink everything they believed about the deep crust. Water was no longer just a surface force that shaped rivers and soil. It was active deep underground, altering rock from within. Where water exists, chemical reactions follow. Minerals break down. New compounds form. Gases build pressure. Heat moves differently. The interior of the Earth was not isolated from the surface world. It was connected to it in slow, invisible ways. Fear grew as these realizations spread quietly among the research teams. If water could survive here, then pressure and heat were not the absolute destroyers they were assumed to be. The models used to predict rock strength, heat flow, and long-term stability no longer felt reliable. Each new meter drilled felt like a step into territory no one truly understood. As drilling continued, the questions became darker. If water could exist at these depths, what else might survive? What other assumptions were wrong? The answers did not come immediately, but when organic material finally appeared from far below the surface, it would confirm a truth far more disturbing than the presence of water. It would show that water was not the most impossible thing hidden inside the Earth. Fossils beyond thermal death. In May 1989, after nearly 2 decades of drilling, the Kola Superdeep Borehole reached a depth of more than 12,200 meters. By then, the project had already shattered several long-held assumptions. Even so, nothing prepared the team for what came next. When renowned geologist Victor Petro examined a newly recovered core sample, he noticed something that made him stop breathing for a moment. Embedded inside the granite were tiny shapes that did not belong there. Under magnification, the shapes became clear. They were microscopic single-celled marine organisms known as plankton. Their forms were familiar to any trained eye. They had rounded shells and clear internal structures. These were not vague smudges or chemical hints. They were recognizable remains of once living creatures, and their presence at that depth should have been impossible. The conditions surrounding the sample were extreme. Temperatures at that depth exceeded 350 degrees Fahrenheit, roughly 180 degrees Celsius. Pressure was immense. According to every accepted biological and chemical rule, organic material should not survive there. Cells should have broken apart. Proteins should have been destroyed. Carbon-based structures should have collapsed into nothing long ago. Yet these fossils were still there. They were neither erased nor reduced to dust. Instead, they were preserved well enough to be identified and dated. Further analysis made the situation even more disturbing. The fossils were nearly 2 billion years old. Evidence showed they had been exposed to repeated heating over vast stretches of time. Still, their structure remained. Even more troubling was their position. The granite around them appeared younger than the fossils themselves. This reversed the normal order of geology. Life seemed older than the rock that held it. No existing explanation could account for this. Shock spread through the small circle of scientists who were allowed to see the data. Some felt awe. Others felt fear. A few refused to believe the results until every test was repeated. Each time, the conclusion was the same. Preservation alone could not explain what they were seeing. The rules that defined where life could exist no longer applied. The discovery raised questions no one was comfortable asking out loud. If organic material could endure such heat and pressure once, then the idea of total thermal destruction was flawed. Life might be far more resilient than anyone had believed. It might adapt, it might persist, and it might still exist in places humans had never imagined. Soviet authorities reacted immediately. Viktor Petro was told to keep his findings within official channels. Reports were restricted. Publication was postponed without explanation. The concern was not ridicule or scientific debate. It was the meaning behind the discovery. If life could exist this deep, then the Earth's interior was not just rock and heat. It was chemical, it was biological, and that realization threatened to rewrite boundaries that had defined science for generations. One question now refused to go away. Life at those depths would require energy. The next anomaly uncovered at Kola would point directly toward where that energy might come from. Hydrogen from nowhere. As the drilling continued, the return flow of drilling mud began to draw quiet attention from the technicians on site. The mud was supposed to rise smoothly, carrying crushed rock back to the surface. Instead, it bubbled. At first, some assumed it was heat causing the effect. But that explanation failed almost immediately. The bubbles were gas. When the gas was analyzed, the result was alarming. It was hydrogen, and not in small amounts. The concentrations were far higher than any model had predicted. This was not residue from equipment or surface contamination. The hydrogen was coming from deep below the drill, released directly from the Earth itself. Hydrogen is not a neutral finding. In biology, it is a source of energy. Many microorganisms use it as fuel. In geology, it signals active chemical reactions, not dead stone. At those depths, such volumes should not exist. There was no accepted process that could produce hydrogen in those quantities under those conditions. Yet the measurements were consistent and repeatable. Even more disturbing was how the hydrogen behaved. Its levels did not remain stable. They rose and fell without a clear pattern. After drilling pauses, concentrations often spiked, as if changes in pressure allowed trapped gas to escape or triggered new reactions. The Earth did not behave like a passive container. It behaved like a system responding to disturbance. Scientists were left with two possible explanations, and both were deeply unsettling. The first was that hydrogen had been trapped in the crust for immense spans of time and was now being released. This alone suggested a crust far more open and chemically active than anyone had believed. The second explanation was even more disturbing. It suggested that the hydrogen was being produced continuously by reactions still occurring deep underground. That meant the Earth's interior was not chemically quiet. It was active. It was generating energy. When these findings were considered alongside earlier discoveries, a pattern began to form. Water was present at impossible depths. Organic material had survived extreme heat and pressure. Now there was a steady source of chemical energy. These were not random anomalies. Together they formed the basic conditions needed for life. The realization unsettled even the most experienced researchers. Some felt a growing fear they struggled to hide. Others felt a sense of awe mixed with dread. The idea that the deep crust might host self-sustaining chemical or biological systems was too disruptive to accept openly. Once again, the response from authorities was swift and cold. Publication was discouraged. Discussion was limited. When researcher Dmitry Vulov attempted to share the hydrogen data with colleagues outside the Soviet Union, his security clearance was suspended. The warning was clear. These discoveries were not to leave controlled channels, but the evidence did not disappear. It continued to build, layer by layer, as the drill moved deeper. No chemical system could function without heat, and the next measurements from Kola would reveal that the heat beneath the surface was far more extreme and far more frightening than anyone had prepared for. When rock began to flow, the last obstacle standing between the Kola project and its goal was temperature. From the beginning, official models had promised control. Even at the deepest planned levels, heat was expected to remain manageable, roughly 200 degrees Fahrenheit. Engineers believed existing materials and techniques could handle it. This assumption shaped every decision, every budget approval, and every promise made to leadership. But reality broke that belief slowly, then brutally. As drilling passed 4,500 meters, temperatures began to rise faster than predicted. Instruments were checked and recalibrated. But the numbers did not change. With each additional meter, the heat climbed more sharply. By the time the drill reached 12,000 meters, temperatures exceeded 350 degrees Fahrenheit. At that point, fear replaced confidence. The effect on the rock was immediate and shocking. Granite, long treated as a symbol of strength and rigidity, stopped behaving like solid stone. Instead of cracking cleanly under pressure, it began to bend and flow. The rock deformed slowly but relentlessly, closing around the drill path. Scientists realized they were no longer drilling through something brittle. They were pushing into material that behaved almost like softened metal. The equipment was not prepared for this. Drill bits lost their cutting edges almost as soon as they touched the rock. Steel components twisted under stress, pipes warped, motors overheated and failed. Entire sections of drill string snapped or became permanently stuck. In several attempts, thousands of meters of equipment were lost when the hole collapsed or seized around the metal.
So hot that the drill head itself was becoming almost impossible to operate due to just the elevated temperatures, just so hot down there.
Each loss was expensive. Each one carried a growing sense of helplessness. What made the situation worse was the realization that this was not an isolated zone. Engineers tried to drill sideways, branching away from damaged sections. But every attempt encountered the same conditions: heat, deformation, and failure. The Earth did not allow workarounds. It responded the same way each time, as if enforcing a limit that could not be crossed. This was no longer a simple engineering problem. The behavior of the crust itself was changing. Increased heat combined with water, gas, and chemical reactions had altered the physical nature of the rock. It became more permeable and flexible. Long-trusted models had no place for this state at such depths. The predictions were completely wrong. Among the scientists and engineers, morale collapsed. Some felt anger. Others felt defeat. Many felt a quiet fear as they accepted that the planet beneath them did not follow human expectations. Reports became cautious and confidence disappeared. There was no dramatic announcement of failure. The project simply began to slow. By the late 1980s, the situation beyond the drill site made continuation impossible. Funding dried up and support vanished soon after the Soviet Union collapsed in December 1991. Without money, without political backing, and without a solution to the heat, the project ended. In 1994, the borehole was finally sealed. Metal caps were welded into place, buildings were abandoned, and the site was left to decay in silence. Yet, closing the hole did not seal the questions it had opened. What the Earth revealed and what was hidden. Years after the drilling stopped and the site was abandoned, former researchers slowly returned to the data. Many of them did so in private, away from institutions and official oversight. When the findings were laid out side by side, the pattern could no longer be ignored. The missing geological layers, the water trapped deep in the crust, the preserved fossils, the hydrogen gas, and the extreme heat were not separate problems or isolated mistakes. Together, they told a single disturbing story. The Earth's crust beneath Kola was not quiet or inert. It was active. It allowed fluids to move. It generated energy. It changed its physical behavior under pressure. It preserved material that should have been destroyed. Every major assumption used to describe the deep Earth had failed under direct observation. The models had not been slightly off. They had been fundamentally wrong. With time, it became clear why so many results were suppressed. This was not simply about saving reputations or avoiding political embarrassment. The real danger was deeper. Kola threatened certainty itself. Geological science had been built on the belief that the deep Earth was stable and predictable. It was assumed to be a record of the past, frozen in place since its formation. What Kola showed instead was an interior that was still active, still reacting, and still changing. For many scientists, this realization was unsettling on a personal level. Some spoke later of sleepless nights and growing anxiety during the final years of the project. They had not expected to feel fear while studying rocks. Yet the deeper truth was impossible to ignore. The planet beneath their feet was not fully known. Worse, it did not behave as expected when disturbed. The borehole itself still exists today. A small metal cap marks the opening. Around it, the land looks ordinary. Trees grow, snow falls. There is nothing to warn visitors that beneath that point lies more than 12 kilometers of drilled rock and broken assumptions. The hole is narrow, but it cuts deeper into human understanding than any other experiment ever attempted. The legacy of Kola is not about how deep humans managed to drill. It is about how much certainty was lost along the way. Every core sample challenged a belief. Every anomaly forced scientists to admit how little direct knowledge they truly had. The most disturbing discovery was not water, fossils, or heat. It was the realization that the Earth is neither simple, stable, nor fully known.